Okay, we're going to get going here. Today we're going to go over lesson 2, and actually I'll make another video that's going to go with this, and we'll go over lesson 3 as well. They're very closely related. Lesson 2 is just a little bit more multiplying and factoring. We're going to get into factoring just regular polynomials as well as multiplying any kind of polynomials. Last time we were a little bit more case specific on difference of squares and squaring binomials. So this time we're going to get a little bit different tastes on those. So the first part here, it's just kind of reintroducing us to the picture and using a table to solve these ones. So if you're using a table to assist multiplying, you'll take one of your your binomials in this case and put it up here on the top, and another one put on the side. This one's x plus 7 and this is x plus 3. So then you just multiply the two together, you get x squared. You multiply these two together, 7x, 3 times x, 3x, 3 times 7 is going to be 21. So that's really all you have to do on those ones. And then you'll just pull out the things that are the same. So we'll look for like terms. So x squared, are there any other variables or terms that have an x squared in them? And it's looking like no. So we can just put x squared out here. The next one then is going to be x, so x to the first power. So since we see, okay, these ones both have an x, how many total x's do we have? So I have 7 x's here and 3 more x's here, so I'm going to have a total of 10 x's. And then the last one, 3 times 7, you're going to have 21, and there's nothing else that'll match. So if we were solving that way, then that would be our answer. You get the table, and then you just combine the like terms. So in exercise 1, it says use a table to find the product. I'll give you a chance to work on that, see what you can come up with using the table like up here, and then come back and I'll show you. Okay, so looking at this, you're going to have to draw a table. And then you'll split these up. So one of them will go on the top, one will go on the bottom. It doesn't matter. I'm just going to put 2x plus 4 on, or plus 1, sorry. 2x plus 1 on top and x plus 4 on the side. So then we'll multiply together. When we multiply these together, it's like you have a leading coefficient or a constant number of 1 out front. So it'd be 1 times 2, you'd have 2, and you multiply the x's together, it's going to be x squared. And then you'll do x times 1, you'll just have x. So then 2 times 4 is going to give us 8, and it's still multiplied by x, so there's still an x there. And you do 4 times 1, that'll be 4. So then to write it out as a polynomial, you have 2x squared, because you've already got this 2x squared and there aren't any other x squareds in here. Then we'll see, okay, I have an x and another x. So this is 1x plus 8x. So I'll have plus 9x total. I have 9 x's there. And then I also have 4. So you'll just put plus 4. So that's what your polynomial will look like. So in the next part here, it says polynomial expression. So there's a couple things we kind of need to clear up here. When we're looking at these variables, each one of these is a term. So 2x squared is a term, 9x, and 4. They're all terms. If we just have one, say I just had 4, that's a monomial. That would just be one of them. If I have x plus 4, that's going to be a binomial. And if I have something like this, where I have 3, that's going to end up being a polynomial. If you have 3 or more, then we're going to start hitting polynomial. But with these ones here, this 4 is going to be a monomial, x plus 4 binomial. Each one of these is a term. So it says here a polynomial expression is either it's a numerical expression or a variable symbol. So these, or it can be if you multiply polynomials together or even add them together, you'll have a polynomial. So that's kind of what it's saying here. The other thing I really quickly want to clear up is if we have something like here, I'll just take this 2x squared. You're going to see this coming up where we talk about coefficients. This number right here in front, that's the coefficient. This right here is the coefficient that we're talking about. So it's called a constant as well because it's a number. You're not going to change this number. The variable we could change. We could put in a 1 one time, and another time we could put in a 2, but the number we would keep the same. So just something to clear up: coefficient, variable, but you'll sometimes hear people reference that as a coefficient. Okay, the next part, it says multiply the following binomials. Note that every binomial given the problem below is a polynomial in one variable. So what it means by that one variable, we're only using x. X is the only variable that we're using here. So it also wants you to write it in standard form. That means that A, B, and C, they're all going to be constants. B and A would be considered coefficients. So you're going to put your x squared first, then x, then your number that's left over. So if I was to demonstrate and show it this one, remember you can either use the table or you can end up foiling it out. I prefer foiling method. If you want to do the table, that's fine, but I'll use FOIL. So I'll do the first, outside, inside, last. So the first one would be x times x, so that's x squared. And then I do x times -7. This negative here would stick with the 7, so it's minus 7x. And then I would have, it'd be inside 1 times x, so it's going to be a positive x. And then we do last, 1 times -7, so that'd be -7. So now, then I'll combine the terms, so I'd have x squared, there's nothing to combine that with. I have a -7x and an x, so when I combine those, it's going to be -7 plus a positive 1x. So that'll end up giving me -6x still, minus 7. And so that's how I'd write it. This is your A, which would be here, but we don't have one, it's just 1. X squared minus 6x minus 7. And so that'd be your ax squared plus bx plus c, your standard form. So I'm going to give you some time, look here, work through them, see if you can find anything, or solve them, multiply them, and then come back and I'll help you out. Okay, so on this one here, x plus 9, x plus 2. So again, you're going to FOIL them out. First outside, inside, last. You should have x squared. And it's going to be plus 2x plus 9x plus 18. Where I get x squared is x times x, 2x, x times 2, 9x, 9 times x, and 18, 9 times 2. So then you'll combine like terms. X squared is on its own, stays that way. You have 2x plus 9x, that's 11x. And then plus 18. Next one, you're going to do the same thing. First outside, inside, last. So x times x, x squared as always. And we'll do outside, so x times -3, so it's minus 3x. -5 times x, so it's a -5x. And then -5 times -3, it's going to be a positive 15. So again, you'll combine the like terms. X squared minus 8x plus 15. Okay, the next one here, you're going to work with fractions. I know it's not your favorite thing to do, but we can do the same thing. First, outside, inside, last. So x times x, x squared. X times -1, negative x. You could put -1x, that's fine as well. 15 over 2 times x. That's going to be positive 15 over 2x, and then 15 over 2 times -1, negative 15 over 2. So then you'll combine the like terms, x squared. So then if we're subtracting 1 from here, this is the same as saying -2 over 2x. So if we do -2 over 2 plus 15, then the bottoms will be left alone, but we can subtract from the top. So it'll be plus 13 over 2x minus 15 over 2. Okay, last one here. So more fractions, more fun. X times x, it's going to be x squared. X times -3/4, be -3/4 x. -5/4 x, -5 over 4x. And then negative 5/4 times negative 3/4. So I'll just write that off to the side. That way we can multiply these out. So something to keep in mind when you're multiplying fractions, you just multiply straight across. So negative 5 times negative 3, that's going to equal 15 over 4 times 4, 16. So 15 over 16. And it's going to be positive, the negatives will cancel. So plus 15 over 16. And then you'll combine the like terms, x squared. Since they both have the same number in the denominator, you just add the numerators together. So negative 8 over 4x plus 15 over 16. So with this one here, it's 3 plus 5. You'll have 8 over 4. You could end up writing that as 2. That's probably the better way to write that as well. Okay, so moving on, it wants us to factor. So factoring is something that we've done in the past. Something to keep in mind is the way I taught it to you before is you're going to split up this 7 so that you can see the factors of it. This x squared is always just going to be x and x. There's nothing to put with it. There's no coefficient in front of it. So when we have the 7 times 1 is a possibility, and that's it. 7 can't be multiplied by anything else to get 7. So for this one, you have plus 7 plus 1. Because when we work back through it, you'll have 7x, 1x, you add them together, you'll get this 8x. And then 7 times 7 is 1. And I'll show that real quick. So x times x. So with FOIL, you have x squared. And then x times 1 plus x. 7 times x plus 7x. 7 times 1 is going to be plus 7. So you have x squared plus, then you'll do 1x plus 7x, 8x plus 7. So there would be how you would check yourself. So what I want you to do on these, go through, factor them like this, and then come back and check and make sure that you have the correct answer. Remember, you'll start here with the second one, see what it's going to be, and different numbers, different ways of reaching that number, and then you're going to see which ones added together will end up giving you your coefficient right here. So give them a try and then come back. All right, so when we're looking at this one, m squared, there's a 1 in front, so you just have m and m. So we're looking at a couple things here to notice. This is a negative, so we're going to have to be multiplying a positive by a negative number. Also, this is going to be a positive number, so whatever we're multiplying together, the positive number has to be bigger. And it has to result in only 1 being there. So if we list out some possibilities, we have 3 times 30, you do 45 times 2, 9 times 10, I think, and you may have another couple in there. You could do a 5 times 18. So when we look at this, when we're trying, we won't be adding them together, we'll be subtracting them from one another. So when we look here, 30 minus 3, that's going to be 27. And if we switch it around, it's not going to be the number we want. So the one that ends up working is this one right here, 9 times 10. So the 10 is going to be positive and the 9 is going to be negative. That way then we'll get a 1 as our coefficient. So plus 10 minus 9. And then we could work it out, FOIL it. So we'd have m squared. It wouldn't be plus, it'd be negative m times negative 9, so negative 9m plus 10m inside, and then the last, negative 90. Then just combine terms, and we end up getting the same one that we started with. So the next one here, k squared, you have k and k. So we need a negative 13. That's going to tell me that this is negative, but this is positive, so we're going to be multiplying two negative numbers together. So for 40, we have 8 times 5, 4 times 10, 2 times 20. So the one that's going to work is 8 times 5. And if we have a negative 8 plus a negative 5, we're going to get 13. So minus 8 minus 5. So then we'll get k squared. If we do first outside, inside, last. K squared minus 5k, negative 8 times k, minus 8k. And then it'll be plus 40. So that'll end up equaling k squared. Combine those two, you get negative 13k because we added them together. And then plus 40. So we're back to our original. Okay, the next one here, 99 and negative 100. So it's a negative. We're multiplying a negative by a positive. For this one, that means the positive number has to be bigger since it's a positive here. So v squared, or not v squared, it would just be v for each of them. So to get that big of a number, the only one that's going to work is 100 times 1. You could also list out 50 times 2, but nothing's going to get closer. You have to do 100 as your positive number times a negative 1. That'll give us negative 100. When we add them together, we'll get this 99. So plus 100 minus 1. So then we can factor it back out. We'll get v squared negative v plus 100v minus 100. So then we have v squared again. Combine those two, add them together. It'd be 100 minus 1v. So that'd be plus 99v minus 100. So this is kind of the basics of factoring. We've done this before. I know it's been a while, so you could very well be rusty. But in the next one, we'll get more practice with factoring. The last example here for lesson 2. So on this one here, sometimes you're going to get a leading coefficient. The leading coefficient is the one all the way in front. So for this equation or this expression, your leading coefficient would be negative 16. So sometimes you get where the leading coefficient is not 1. The first step in factoring should be to see if all of them have a common factor. So here we'll see that all of them are actually can be divided by 16. We can reduce that number. So it makes it a little bit easier. Same with like this one here, they can be, you can take a 2x out of each one of them. So you take 2x and then you actually get a difference of squares where you can factor it out. The same is going to be true down here. So if we have negative 16t squared plus 32t plus 48, we can actually end up factoring out 16. And we want to take out negative 16. We don't want to leave a negative as our leading coefficient. So if we take out, so I'll just rewrite it, negative 16t squared plus 32t plus 48. And I'll round those out so you can tell if they're t's. So we can take out negative 16, and that's going to give us with t squared plus, so if we take 32 divided by negative 16, it's actually going to make that now a negative 2t, and this one is now going to be a negative 3. Since we took out the negative, then we have to divide all of them by negative. So now we can look for ways to further break it down. So now we have negative 16 t squared minus 2t minus 3. So we can look here, okay, this negative, we have to multiply a positive times a negative, and we're going to end up with a negative 2. So 3 can be broken down as 3 times 1. So then we have negative 16. So we're going to have to make the 3 negative and the 1 positive so that we can get a negative 2. So then it'd be t, so this is going to be, we'll put a minus 3 here, plus 1. When you're doing these, as long as your leading coefficient when you're factoring is 1, it doesn't matter which one you put it in. The next one that we're going to do where the leading coefficient isn't 1 and we can't factor it out to be 1, then your leading coefficient is not going to be, or then it does matter where you put these. So that's just something to keep in mind and be careful of and make sure that you're aware of. But yeah, that's it for lesson 2.